So in this topic, we are going to cover some of the advanced threats that we see on the field, and also some of the best practices and challenges that you guys face when you are protecting mobile apps, right? So I'm Mohamed Kerroumi. I work at the Imperium for the past 7 years now, and I'm helping customers or developers like you guys who are protecting their apps. So a little bit about myself. I've been in the space for almost quite some time now. I started as a pen tester, and then I moved as a software developer and mobile app security. So the picture that you see on this one, it's a voice over IP phone, because I started my first experience, my first job in France at Alcatel, and we worked on this phone. And the goal was try to break and find vulnerabilities by sniffing the network, right? So we were using like Ethernet cable, and we tried to find vulnerabilities there. So we managed to extract and capture the key, and after that, we could decrypt all the communication that could happen So imagine in your company, if someone is talking on the phone, you can basically get all the communication going on, right? And this type of attack was, I would say, very easy to do because the key was not protected. It was in clear somewhere in the network. So I'm telling you all this because, now we can see almost the same attack that we can do it, but it's not, you don't need any Ethernet cable. You can do it directly on the mobile devices, because we use our mobile to do almost everything. Like this morning when I just wake up, I check my emails, and you can use it for payments and almost all the stuff. So, but you can also do the same attack as before. If your data are not protected, right? You can exfiltrate, you can get the key, you can dump the memory. And we're gonna cover in this talk some of the attacks that can be done right now. So here, basically why the apps are being targeted. So as you know, attackers, whenever there is value, whenever there is an interest, they will try to break into the apps, because the apps are an easy target, basically. They can exfiltrate some sensitive data from the application, and they can also, try to break into your backend, because the application itself will always be connected. So the app can access everything, and it's always connected to a backend. This is where they can, for example, try to find some API keys and try to access your backend. And also, most of the apps don't have real security control or mechanism. And we know that because as Imperium, we work with Google, and we have analyzed every app that gets pushed on the store. Our engine will do the analysis of the app, and we kind of know what's going on in the field. We kind of know how many apps, are protected. And we see on this analysis of 1 million apps, there's almost 80% of apps that doesn't have, app protection, proper protection against, reverse engineering and tampering. And that's a huge number, right? And actually, if you are interested and you want to get your app scanned, you can see us at our booth, and we'll be happy, to scan your application and give you a report of the findings. So the other thing that we see, we will be covering the type of attacks. So reverse engineering is one of them, which is static analysis. So it means the app is not protected against, static attacks and tampering. And another thing is the on-device protection, which is also another 82%, where the application doesn't have a protection against routing or malware or emulator. So some attacks, for example, will target applications. They will be running on emulator, and they try, for example, to spoof the camera and do other things. So it's really important to protect your app and to detect, for example, routing, because when you are on a rooted device, you can access almost everything. It's open. You can access the file system. You can find, read the memory. And the last thing is the data protection and key protection. So it's really important to protect your data and your keys. So as we have seen before in the example, the key is the, if if you find the key, you basically have the data, even if your data is encrypted, right? So there's a real need for protection of data of keys and the keys. And we're going to start first by talking about static threats or static attacks. So I see basically two categories. There's the static threats and there's the dynamic threats. So static threat is when you go to the store, you download the APK, and then you can try to find secrets and sensitive data. So it could be certificate, API keys, or try to understand the code and logic. Or you can do later is just recompile, build a clone of the application, and put it on another store. This is what we call modding. And so this can happen completely offline. The app doesn't need to, to run. And there are a lot of tools who can do that, like extracting the data and then repackaging to create a new application. So here we see, what I was talking about, which is modding. This is where we change the APK. So we can change the APK and the assets, right? And the main goal here for attackers is basically to unlock, for example, premium features without paying. So if you have in your app some premium features, or if you rely on ads for revenue, this is very easy to do. There are even some, automatic framework tools, we call them patchers, that you can use, and it's just one click when you can apply the patch. So the way they work is that they have a set of automatic scripts that target common features, and they will apply automatically. You can see one of them here, where you can disable the license verification or disable the ads from the app. So this is the easy way. The other way is where attackers will target some specific application, right? So they will find the app, and there are 3 steps in there. They will decompile, so they get the app from the store, decompile it, try to understand, and try to find where they need to modify it, repackage it, and that's it. Job done. They can have it on the website, and anyone basically can download the app with the premium features for free. So how basically we can protect against this type of attacks, which are like static attacks? Most of the time, what we see is if you reverse engineer an app, there's open source tools out there. Some people will put even certificate in the assets. So assets should be really important and should be protected. They should be encrypted. We should not have any keys, any API keys, or anything visible in the code. So the first thing is protect your code. Make sure that the code is completely protected, is not visible, and also protect your resources if you have any important things in the resources, right? So there are tools, open source tools out there. Of course, maybe you are already familiar with R8 or ProGuard. Actually, I would like to know how many of you knows about R8 or use R8 and ProGuard? Wow, that's a huge number. Yeah. It's very good. I mean, ProGuard R8 is a good first step, but I would say it's not enough, because ProGuard R8 will give you the first basic obfuscation. What we mean here by obfuscation is class renaming. Class renaming, as you see in the picture, I take the classes and I modify the name to make it difficult to understand. So the name of my class, the name of my method will be changed, but it doesn't mean that my code is protected. The code is still there, and the code is visible, right? So class renaming, ProGuard R8 are really useful for shrinking, optimization, but still they are not protecting the code by itself. An attacker can still understand and modify this very easily. So what can be done in this case? We can have more advanced protection. ProGuard is great, so we can still keep ProGuard R8. It will do the class renaming. But the benefit by adding other tools or other techniques is to make sure that the application is protected against modification. So someone cannot take the app, modify it, and repackage it. So this is one thing. We call it can be integrity check. where you will add some checks into your code and make sure nobody can tamper or change your code. All right. The other thing that we can do is have advanced control flow obfuscation. So make sure that the code is not visible and it's really obfuscated. All the code, not only, but the way we do it is we will focus mainly on the sensitive code that we want to protect. We don't need to protect like everything. But we need to make sure that the protected code is very protected inside when we do the reverse engineering of the app. And of course, resource protection, make sure that our assets, whatever we put in our assets, are encrypted, right? So these are some of the techniques that we can be used in the top of R8 and ProGuard. So now let's talk about runtime threats and runtime attacks. So we have talked about static. In the runtime, this is where you need the app to be running. So it means that what I can do in this case is I run the app, but I will run it in modified environment. So I will run it in a rooted device. I will use some instrumentation tools. And what this gives me is that I can almost debug the application at real time. So it's like you are using a debugger. You can see the values, you can see the memory, and you can tamper with this in real time. So for example, if your application is talking with the backend, I can modify all the values and send. I can bypass the authentication. If you have implemented, for example, some routine open source detection, you can bypass this, or SSL pinning. You can bypass it with the hooking and instrumentation. And we're going to cover some of the tools that's out there, which are very popular. All right, so the first one I want to talk about is Magisk, right? So recently we have, a fintech company who reached out to us and say, okay, we failed the pen test. We had developed our own, root detection, and recently we just failed the pen test. So it was working for quite some time, but now it's not working anymore. And what they did is that they implemented, play integrity, and they failed again. The reason why is that the tool used by the pentest company was very advanced. It's called Magisk. Maybe some of you know it. I don't know. How many of you know about Magisk? Yeah, I mean, that's great. But the first time I tried to, install Magisk, I was very confused because there are so many forks, so many versions, so many modules that you can install. And the reason why is that Magisk was developed specifically for escaping and hiding the root detection. So because the people who develop Magisk, basically they want to have their rooted device, but they still want to have their banking app working there. They still have to access the payment to do everything. So Magisk gives, it's a systemless routing, which means that they don't change the file system, the system partition. They just change the booting partition, and it makes it easy to run any application and hide the routing from the using Magisk. And also, the most important thing is that there are almost like 300 contributors, 300 people. It's almost the size of the company I'm working for, who are working on Magisk and developing all the variants and fork. So the current, if you develop your own routine detection or open source routine detection, it's clearly not enough to compete with Magisk and the variants that's out there. And the other thing that we see is the how we call it, FRIDA, or instrumentation. So FRIDA is also a very powerful tool because it has it's like a framework where you can inject scripts at runtime, and there are a lot of scripts, for example, to bypass the routine, to bypass the SSL certificate, and it's really useful for researchers, but attackers use it as well to bypass all the protections, right? And yeah, so we have talked about routine instrumentation. There's also another threat, which is malware. So malware are really have really evolved. So you can see here, just in the last 3 years, there's a big improvement on how they operate. And actually, malware right now can do completely automatically things like account takeover or payment, because they abuse right now accessibility permission. And for example, there is a story about a woman who went to a bubble tea store and she wants to get like a free bubble tea. So she scanned the QR code. It brings her to a website. It was a phishing website where she downloaded the APK. She installed it. She granted the permission to get her bubble tea. But nothing happens after. She went to sleep, and then later on, when she woke up, she saw her bank account completely empty. So what happens? In fact, the malware, when you grant the accessibility permission, it will act like an agent inside the device, and it will control the screen and also control the keyboard. So it can, basically, if you go to your bank account, it will have like an overlay, the same as your bank, right? The same UI, so you will just type your PIN, and it will record the PIN, and then later on, it can replay everything automatically. And even if the bank is using OTP for the verification, the malware will intercept this OTP password, type it, and perform everything automatically without even it's happening, right? And some of the recent malware we have analyzed is it can even operate while the device is locked. So even if you lock your device, you will not know something is happening out there. So this is the type of threat that we see right now, especially in Asia. It's growing very quickly, and this is where there is a need for app, what we call on-device detection and protection. So in general, when you develop your app, you think that your app will run in a safe device, safe environment, but the reality is that the application will be running on compromised device. It will be running on a device that has a malware, because people will, for example, download a lot of side-loaded application from different stores that can contain some malware. So you need to be aware that the environment where the application is running can be compromised. And you need to take into account when you develop your application that all the secrets, all the keys, everything, they can be seen on a rooted device. They can be instrumented or changed, right? So it's important to have what we call observability and to be able to know what's going on into the device. If there is anything happening into the device, you can, for example, know that this is a rooted device, this is instrumentation is going, and you can get this information to either block the app or stop the app from doing for example, a transaction or anything sensitive. All right, so the last thing I will cover here is protecting the data and keys. And so keys and data are really important, as you know, because if you get access to the key, you can access almost everything. And it's very important to make sure that we don't keep any sensitive keys, hard-coded keys in our code or inside the assets or even shared preferences or anything sensitive there, because on a routed device, you can access everything. And the last thing I want to cover now is the challenges that the developers are facing. And I show you here a picture. This is a millefeuille. So I'm from France, so I love millefeuille. And it's security always remind me of this millefeuille because it's layers, And millefeuille means like it's 1,000 leaves or 1,000 layers. And security, you don't need to have 1,000, but you just need some kind of layers there. So let's say you have a layer for static protection, obfuscation. You have a layer for integrity protection, another layer for routine detection, etc., etc. And basically, there's a very interesting, and I recommend you to check it. It's called MASVS. It's a standard. It's a new standard for verification, mobile app security verification standard from OWASP. And it's been used now by a lot of pen test companies and organizations to verify their application security. So some of the challenges I see by working with developers is that, security is always something that, someone, you keep it for the last thing. Like, okay, let's add some security at the end because I need to focus on developing my main features, right? But what should be done in general is to add and think of security at the beginning and to know how it can be integrated in your, for example, CI/CD pipeline, how you do the protection, how you do the testing as well. And there's also a lot of awareness and training that needs to be done for developers in terms of security to understand and use the tools that are out there. They are open source tools. Try to verify their application. And so we need to make sure to protect against these threats, static threats, and also dynamic threats, right? And yeah, so thank you very much for your time. I hope that was useful. If you need anything, you can come see us in our booth. And if you want to get your app scanned, we'll be happy to do that. Yeah, thank you.